Let's do example 7, question 1. We are given this fx and we need to find whether fx is continuous at x equal to 0. So we're talking about continuity, therefore we have 3 conditions that need to be applied. And then it says state your reason. So basically, this condition will be your reason of why fx is continuous at x equal to 0 or not. So if you look at our fx, you can see that we have modulus. Modulus means that it's going to give you 2 answers, and hence this is going to be a piecewise function. So write this function here and here, but change this to become bracket. But don't forget to write whatever inside the modulus here and here as well. For the first row, put positive sign here and more or equal to 0 here. For the second row, put negative here and less than 0 here. So now we need to simplify our piecewise function. Here there's nothing for you to simplify, but for this one, you can cancel out x over x. And hence, for the first row, this is just 3 plus 8x when x is more or equal to 0. And for the second row, this is actually negative 3 plus 8x when x is less than 0. And this is the new fx, so do not look at this previous fx anymore. Just look at this fx only. Note that this is a piecewise function, so draw a number line. So look at this number line in order to do the 3 conditions. The first condition is fc is defined. If you look at our question, we need to determine whether fx is continuous at x equal to 0. So in this case, c is 0. So this means that we need to find f0. f0 means that you're substituting x equal to 0 into fx. So if you look at this number line, x equal to 0 means that you're using the dense circle. So the function that has the dense circle is this function. So you're gonna substitute x equal to 0 into 3 plus 8x. So substitute 0 into x, and the answer is 3. The second condition is the limit of fx as x approaches c exists. C is 0, so we need to determine whether this limit exists. So you need to consider x approaching 0 from right hand side and x approaching 0 from the left hand side. As x approaches 0 from the left hand side, we can write down limit fx as x approaches 0 negative. And from the left hand side, this is function fx. So now just substitute x equal to 0 into x, and the answer is negative 3. For the right hand side, x is approaching 0 from the right hand side. So you can write the limit like this. And from the right hand side, the function is 3 plus 8x. So substitute x equal to 0 into x, and the answer is 3. So if you determine both answers on the left and right hand side, you can see that they are not the same. So you can write down limit fx as x approaches 0 negative is not equal to limit of fx as x approaches 0 positive. So you need to show this conclusion since they are not the same. Therefore, if the left hand side and the right hand side limits are not the same, does the limit exist? The answer is no. The limit fx as x approaches 0 does not exist. For the third condition, you compare condition 1 with condition 2. For condition 1, we have f0, which is 3. And for condition 2, we have limit fx as x approaches 0 does not exist. So this is 3 and this one does not exist. Therefore, by comparison, they are not the same. And hence, fx is not continuous at x equal to 0. So you need to understand that in order for a function to be continuous at a point, all three conditions must be met. But for this one, you can see that the third condition fails. That's why it is not continuous. For the second question, the continuous function gx is given here, and hence we need to find the value of a, where a is a value of x. So this is piecewise, hence you need to draw your number line first. Note that gx is a continuous function. So if it just says a function is continuous, you're gonna assume that it is continuous from negative infinity until infinity. So this means that function gx is continuous everywhere. So if they are continuous from negative infinity until infinity, this means that at x equal to a, they are also continuous. And hence, you can apply the three conditions at x equal to a. Condition 1, fc is defined. So you know that fx is continuous at x equal to a, and this is c. And hence, fa is defined. This means that you're substituting x equal to a into fx. So x equal to a means that you need to look at function that has dense circle, which is this one. I'm sorry, it's supposed to be ga is defined. So it's supposed to be gx instead of fx, sorry. Condition 1 is ga is defined. Substitute x equal to a into gx, which is this one. And we will get 3a minus 4. But note that this doesn't answer our question because we need to find the value of a. So this means that condition 1 can be cancelled out. Okay, so let's continue with condition 2. In this case, c is a. So we need to consider x approaching a from the right hand side and x approaching a from the left hand side. As x approaching a from the left hand side, you can see that the function is square root 6 minus x. Substitute x equal to a into x, and we will get square root 6 minus a. For the right hand side, as x approaching a from the right hand side, the function is 3x minus 4. So substitute x equal to a into x, and we will get 3a minus 4. So we know that gx is continuous at x equal to a. If they are continuous, the left hand side limit should equal to the right hand side limit. So both of them should be the same. So you can write down square root 6 minus a is equal to 3a minus 4. Solve this to find a. And you can see that this is quadratic. Rearrange so that one side is 0. Bring 6 minus a to the right hand side. And we will get 0 equal to 9a squared minus 23a plus 10. So use your calculator. A is 9, B is negative 23, and C is 10. And hence the answer is 5/9 and 2. So 0 is 9a minus 5 times a minus 2. And by solving, you'll get a equal to 5 over 9 or a equal to 2. So this means that when a is these values, gx will become continuous from negative infinity until positive infinity.